Hello viewers, welcome back to our channel. Today we are still on chapter 4. We want to talk about how to solve systems of differential equations. Today we shall talk about solving systems of differential equations using elimination method. Here we shall be given a system of first order differential equations. First thing we have to do, we have to first eliminate one variable and obtain one solution, i.e. first eliminate y so as to get a solution of x at t, and then we use substitution to find our solution. I think here we shall need to first have an example for us to understand more. Just deal with an example, then we shall get what to do in an example. Now our first example, because I need space, let me first put off this, I need space. Then I'm going to say you solve use elimination method. Say our first example, example 1, we shall have our system is this one: x prime plus 3y y prime equals to x minus y. But even condition that x at 0 is 2 and y at 0 is 4. We are saying that in this method of solving systems, what we have to do first, we have to eliminate one variable. And then we shall always eliminate y. How do we eliminate y? We first do the same thing we have been doing. We differentiate the second time this x. We say x, the derivative equals to x derivative plus 3y derivative. But you know that y derivative is the same as having x minus y. I have x derivative equals to x derivative plus 3 into x minus y. Then I have x derivative equals to x derivative plus 3x minus 3y. But remember, 3y is this thing we have here. Then for me to make sure the side, I just take this side, take this on this side. Then I'll have x double derivative equals to x plus 3x now minus 3y. 3y is this thing. Therefore, it's going to be minus x prime minus x, like that. Then I'll have x double prime equals to x single prime plus 3x minus x prime plus x. From this step, we shall need just not show that this is the same thing as having this. If I bring this x and this, the x prime is going to the high answer. I have x double prime equals to, these things are the same. I'm going to die off. I have now 4x equals to 4x, like this. Then the same as having x double prime minus 4x equals to 0. At this step here, we have eliminated y from our equation, and our system is just transformed into a single equation. Yes. Now from this step here, let us find out the solution in terms of t, in terms of x. Sorry. Then for this solution, I just need to form my auxiliary equation. As we say that auxiliary equation, because this is second order auxiliary equation, it's going to be my r squared minus 4 equals to 0. Therefore, my r equals to 2 and my r1 equals 2 and my r2 is negative 2. Now, for me to get the solution, or in terms of t, I have my x at t is the same as having c1. Remember, my x1 at t. So let me first write my solution is here. Not confuse you. If I write my solution is here, I have that my x1 at t is the same as having e power, remember r t, then I have 2t, then my x2 at t is the same as having e power negative 2t, and hence my x at t is the same as having c1 e power 2t plus c2 e power negative 2t as my solution in terms of x. Now the second step from finding auxiliary equation, I'm getting a solution, the first solution in terms of x. Now here, I need to differentiate this x. I'm saying I need to differentiate it. I'll have now x prime at t, the same as that. I'm differentiating this way to t. I have now these two come down. I have 2 c1 e power 2t. Yes. Now minus, because I'm differentiating this one, I have negative 2 c2 e power negative 2t. Now, for my equation 1 here, from this equation, from x plus 3y, from x derivative equals to x plus 3y. If I make my y decided, I have now y equals to 1 over 3 x derivative at t minus x at t. Therefore, we're able to get x at t as the same as having 1 over 3 into. Now here, I just replace where there is x derivative, I have it. When where there is x, I have it also here. Therefore, I'll be able to get my y at that particular t. Then it's the same as having x derivative is this one. I have 2c1 e power 2t minus 2c2 e power negative 2t. Then minus x is this one. I have c1 minus c1 e power 2t. Because of the negative, so become a negative. I have minus c2 e power negative 2t. This way. Therefore, my y at t is the same as having, if I add, this is just to be negative, this is 2, and then this minus 1, I have c1, then I have a third into c1 c1 e power 2t, and then I have negative 3 minus 3 c2 e power negative 2t as my y. But remember, we are given conditions that x at 0 is 2. Then if I put there, if you say x at 0 is 2, means that if I put where there is t, I put there 0 in the value of x, I have 2. Then this means that my 2 equals 2. Where if I put c1 e power 0 is going to be c1, then plus c2 e power 0 is going to be c2. This is my equation 1. Then we said y at 0 is 4 from this equation. Then if I put here 4, I have 4. It means that 4 equals 2. Then if I put in c1, if I put in, I'm putting in c1. So I'm putting in t is 0. I have now a third into c1 minus 3 c2. Equation 2. Now, if I solve these two equations simultaneously, I will be able to obtain my c1 and c2. You solve them anyhow you want. You may press the calculator, you may do elimination, you may do substitution, any formula you use, you get the answers. For my calculator, I got that my c1 equals to 9 over 2, and then my c2 equals to negative 5 over 2. Then I can easily write my solutions now without the t in them. Therefore, my x at t, if I put off this to get space, therefore my x at t is obtained by me putting where there is c1 9 over 2 e power 2t, then plus where there is, this is 9. Now where there is c2, I have negative 5, this is going to be minus 5 over 2 e power negative 2t. And then my y at t is going to be the same as having, I'm saying my y at t. What is my y at t? My y at t is this function here. I will be having a third into c1 is 9 over 2 e power 2t minus, then I have 5 over 2, and then this is a 3 here. Then I have something like 15 plus, now because negative, plus 15 over 2 e power negative 2t. And then by that, I'll have sort of a system of differential equation using elimination. Now from this example we have done, you've seen that we have various steps we have to follow while solving a system using elimination method. The first step, we say that you have to eliminate y, and that this will enable us form an auxiliary equation you've seen here. For me, from forming an auxiliary equation, I will need to solve this solution and get my solution is my x1 at t, and then my x2 at t. I get my general solution at xt. So it should be this one. The third step is for me to differentiate this x that I've got. Then I substitute. I make what I started from the first equation. Then I substitute in the x prime minus the x. Then after substituting, I'll be able to get my y at t, which is this one here. Then when given the conditions, x at 0 is 2, therefore they want me to get the C1 and C2. Then after me getting the C1 and C2, I just place them back into my equation, and then I will be able to solve the system using elimination method. I think this one could be enough for you because this is just a simple example of a this system is homogeneous. Now just take a case when a system is non-homogeneous. Now solving a non-homogeneous system using elimination. Yes. Allow me to take you through the second example as we enjoy this concept. I think I'm not speedy, you'll be able to get me. The second example, I have first put off this. Yes, for the second example, we shall have a non-homogeneous system, such as example 2. We have something like x prime equals to x minus y plus t, and then y prime equals to x plus y, and then also given conditions that x at 0 equals to 2 and y at 0 equals to 3. As we said originally, that the first step is for us to eliminate one variable. We also eliminate y, as we say, so as to get a system in terms of x solved, and in terms of x solved. Then if I say the first time, second time, I have x double prime equals to x prime minus y prime. Now if I say t in terms of t, I have 1. So I'm switching this way to t. I have 1. Now I replace where there is y prime with the second equation. I have x double prime equals to y equals to x single prime. Now where there is, I have plus 1, then where there is minus y prime is the same as having x minus y because of this negative here. Then I have my solution as x double prime equals to x prime plus 1 minus x. Now y, I want to make y the subject in the first equation. Minus y is going to be the same as having minus, now it's going to be x prime. If I make y the negative y the subject, I have x prime. Sorry, if I make negative y the subject, I have plus x prime. If I make negative y the subject, this one comes inside. I have negative x. I have x prime minus x minus t as my y. So that's step. Therefore, how I will go to put my equation like x double prime equals to, this one should be 2 x single prime, yes, and then I have this negative and then this negative, minus 2x, yes, minus 2x, and then I have this and this one, minus 2x, then I have a t and then I have a 1, plus 1 minus t, yes, plus 1 minus t. Therefore, if I take this x as this side, I have an equation like this one, x double prime minus 2x single prime like this, then plus 2x equals to 1 minus t, and then this equation is the solved equation without the y. I have successfully eliminated the y in this equation. Now my task is for me to find the solution of this solution in terms of x at t, and then I'm saying that this equation here, it is a non-homogeneous equation which I need to solve using the method as we know. I may use the method of uncertainty coefficients. I use the method I want to use. Now, for me, I want to use the method of uncertainty coefficients to solve this equation here. I would say that the first thing you need to first find the complementary solution x at c at t. This one, where you first have to first solve this system, this homo system only. I'm saying that I want first get the complementary solution x at t. I get it in each way. I get that x double prime minus 2x single prime plus 2x equals to 0. Then I formulate my auxiliary equation. This is chapter 3. These videos are there already. How to solve these equations shall be show them already in chapter 3. This should be r squared minus, this should be r squared, yes, minus 2. This is r squared minus 2 r plus 2 equals to 0. Then for me here, now here I will need just find my roots. Then here find my roots. I will say that my roots I'm getting here using the calculator. I'm going to say that my roots are going to be conjugate. I'm going to be complex roots. My R1 is going to be the same as having R equals to 1 minus 1 like this, and then my R2 is going to be its conjugate 1 plus I. And then here I think we shall be able to get our combination solution by saying that our x at c combination solution at t the same as having, now this, remember you say that it is e power alpha t, and now alpha is 1, then I have e power t into now a cos beta x, so a cos beta t, then my a cos beta, my beta is 1, then I have t, then plus b sin beta t, then I have b, my beta is 1 sin t. Then this will be my complementary solution for this part. For this part, we did this chapter in the previous videos. If you want to get me how we are solving this solution, just go and look in the previous videos. You will see how we got arrived to this answer. Now the next step is for me to find out the particular solution for this equation. Yes. Now I will not let for me to find my xp particular solution for this equation. I'm going to say that we get our xp equal to, because I'm seeing something like I'm seeing how, because this equation is in this is an equation which is linear. Since my equation is in this format, linear equation, then I want my xp to be ax plus b, as we saw in the previous videos. Therefore I say let my xp equal to ax plus b because it is linear. Now refresh the first time, shall have xp first derivative equals to a. Since now we have our equation is going up the second derivative, then I have to check it twice. That my x double derivative at p equals to 0. Then if I substitute back into this equation here, I'll be able to get my xp, which is my particular solution. Then on substitution, yes, shall have x double derivative is 0. I have 0 minus 2x second derivative, which is a, then plus the 2 into x. My x is ax plus b equals to now 1 minus t. Then it's the same thing as having negative 2a plus 2ax. So this is not x. Remember, I'm finding in terms of v. This should be at, not ax. At. I'm measuring in terms of x. This would be at. Then I have at here also. Then plus 2b equals to 1 minus t. Now this step here allow me to compare coefficients. If I compare coefficients of t power 0, anything that has t power 0, I'm going to have my negative 2a. This side has t power 0 as the coefficient, and then plus 2b equals to 1, and then my t power 1 is going to be anything that I have to have 2a this side equals to negative 1. Therefore my a is negative a half, and finally my b is, my b I think is going to be 0. If I put in a negative a half here, I have my b as 0. My b is 0. Therefore I'll be able to write my particular my solution for this x at t. I will say that my x at t is the same as having xc at t plus xp at t. Then if I combine these two equations, I'll have something like my xt at 0. My xt is the same as having my e power t cos t plus b sin t, now plus my solution I've got here at, sorry, here I'm going to say that my xp the same as having, remember it is at plus b, but my a is the negative a half, then I have a half t, then here I have to say minus a half t. This is going to be my x at t, my solution at x at t. That is the second step we are doing. Now the third step is on first differentiating this one. if I'm able to differentiate this x at t, then I make y the standard here, then I will be able to find my y at t. Then allow me put off this as we can go ahead and we see how we find our y at t. Then for at this step, let me differentiate x at t. By differentiating, I have, remember now, I'm differentiating this way to t. This is product rule. If I keep e power t as constant, then I differentiate the bracket. If I differentiate because I have negative sign, then I have negative a sin t, then plus b cos t, like this. Remember, I'm just doing what? I'm differentiating product rule. I first keep this constant, I differentiate this one. Then now I'm going to differentiate e power t plus e power t. Now I keep the bracket constant. I will have a cos t plus b sin t in this way. I think you're able to see this side. Then if I now differentiate this one, I have minus, I have respect to t. That way. Now my task is what? I think it input of this to have space because I need space. Now from here, my task is for me to get my y at t. But from first equation, from equation 1, my y at t is what? If I make y decided here, what do I have? I have that my y comes inside this one, goes inside. I have x plus t like this, then minus x prime. But now I have everything. I have x, which is this one. I have x prime, which is this one. Then I have a t. Therefore, I'm able to find my y at t. Now, let me find my y at t. Then, I think we can simplify this one more easily. If I put this one here, minus a half. For me, let's just open button and simplify this thing easier. Then x at t here, just let's come back here. X at t is the same as having, now this is the same as having negative a e power t sin t, like this, plus b e power t cos t, like that. Now here it's not having plus a e power t cos t, and then plus b e power t sin t minus a half. Now this is the same thing as having, if I want to put the things with cos together, on the cos together, I have, this is the same as cos, this is cos. I have something like a plus b e t cos, yes. Okay, even this e is common. I have e power t outside. Now a plus b cos t, then plus, now if I want to put the things of sign together, I have b then minus a. Then I have something like b minus a cos, sin t, then minus a half. I'm just simplifying this step, just step there. So as I can use few steps here. Now coming back to my y t, I've made my y decided from this equation here up by bringing this y this side and then bring this on that side. I have something like that. Therefore, from here, I'll be able to write that my y at t is the same as having x. My x is what? This is my value of x. I have something like e power t into a cos t plus, okay, if I allow me, okay, this way, plus b sin t minus a half t, then plus t, yes, plus t. I'm just doing this part now. Minus x prime, this is my x prime, minus e power t a plus b, like this, cos t, then minus, then e power t comes inside, minus e power t again, b minus a sin t, then minus, confuse this and the plus a half. So that is the statement we have here. Now, how can we solve this one? Is I'm seeing now et a cos t. I have now et a b cos t. Et is common. Et is common. Cos t is common. Cos t is common. This here, then this here, but it's minus. Therefore, I have this is the same as having et now a minus b. Therefore, I have minus cos t. Now I have now et b sin t. Then I have minus et b minus a sin t. Then therefore this b will come inside here. I will say b minus b, then minus a, which is plus a, plus et a sin t, like that. Then I remain this a half t plus t, so it should be plus a half t, and then plus the other half, which is that side. I think there also 12 in that step as my y at t. But remember, we are given initial conditions. I just wanted to leave this t here, x at t here, for a reason. Don't confuse you. Now from this, I think from here, can we put in our initial conditions? It said x at 0. If I put in x at 0 here, I'll have 2 equals to, where there is x, I put there. Remember, this one was, so here there was t. Where there is x, I put there 0. What is cos 0? Cos 0 is 1. Therefore, I have here something like 1 into a. Therefore, my a is 2. Because this is cos 0 is 1, cos sin 0 is 0, and then t is 0, and then this is 1. Therefore, my a equals 2. My a is 2. Therefore, my a is 2 from this equation here. Now, if I put in 0 at here, my y at 0 is equals to 3. So you have it already. Y is equals to 3. And if I put in 0 here, I have 3 equals to. Now, if I put I'm putting in 0. I'm putting in 0 where there is t. Cos 0 is t. Cos 0 is 1. Then I have negative b. Yes, and then this is going to be 0. Then this is going to be 0. They are plain plus a half. And what is my b? My b is going to be, if I bring this a half this side, I have my b is going to be equating to negative 5 over 3. Therefore, my b from calculation is going to be negative 5 over 3. By just being this b this side and then this on this other side, I want to have negative 5 over 3 as my b. And therefore, I will be able to rewrite my x, make my x as t, and then my y as t with ease. So this is over 2, eh? This is negative 5 over 2 here. Because if I bring this 3 minus a half, I have something, then divide by negative, then I have something like this. It says 3 minus a half, I have 5 over 2. Then by this negative, they have this one. This is going to be my b. Therefore, I'm saying that from this step here, I will be able to write my y at t and my x at t with ease without the b and the a in them. Yes? Then, finally, I can write my x at t and y at t with ease without the a and b. Yes. Therefore, my final solution without the b and a, my constants, is going to be like this. My final solution is going to be x at t equals to, my x at t equals to x at t equals to e power t is e power t into, now instead of me writing a, I'm going to put there 2 cos t. Now instead of me writing b, I'm going to write there this one, minus 5 over 2 sin t, then minus a half t, that two. And then my y at t so should be the same as just writing this one without these negatives. I have e power t into, now I have cos Now remember b is now 5 over 2 cos t, and then a plus 2 sin t, just like that. Then plus a half t plus half, just like that it is. I think I'm able to, I've tried to explain how we solve differential equations, systems of differential equations using elimination method. I think you can try out other numbers. Where you find any hardship, just feel free to contact me via my number. I shared it last time. I think I can also share it today. I'll type, write me on WhatsApp. I'll be able to answer your questions. This is my number. Just feel free to write me on WhatsApp. I'll be able to see how I can help you. Thank you for watching. Like, subscribe, share, and comment for more videos like this.